Alright, this is just a quick video to show you what I'm doing with a 3-phase energy metering IC and an Arduino. Alright, this right here is an ATM90E36 that I've been working with. Link in the description if you're interested in. Omega, and these things here are from a different project, but I'm just using them to learn how the chip works because these I've designed for a single phase application. Hence, 3 of them make a 3-phase. So on them I've got a transformer to step down the voltage to one that I can safely measure with. Current transformer to measure the current, and they all sort of divvy up. That right there is what I've been using as a sort of variable power supply to check it out and calibrate it. So you can actually, if you've got a steady supply, you can actually get a better calibration, but just for near enough's good enough. Right now that's alright. Alright, it does look a bit sloppy, I'll admit that, but this is all work in progress, and final product will be much cleaner and much smoother. Alright, so looking at the board, these 3 sort of headphone jacks are used for the different currents. So you've got, I've got 3 in use here. Now that's for the currents A, B and C. And the 4th one is for neutral, so you can also measure the neutral current, which is pretty cool. Over here is the pins for A, B, C and neutral volts, and across here is your SPI pins, and sort of like if you look at a smart meter, you'll often see a red flashing light. Some of those pins have been brought out, and you've got your power connectors. Now this one works at 3.3 volts. Pretty basic what's going on with the Mega. It's just into the SPI pins, and I've got the power coming through to power it. So let's show you how it works. Alright, so as you can see, I'm applying some volts now, and you'll see on the screen it sort of goes up. Now these are sort of ballparky numbers. They're pretty close, give or take 100 millivolts or so. The reason for the difference in each one is more the transformers themselves. Each transformer has a different characteristic, so just having one blanket calibration won't work. You have to actually calibrate each phase individually, and I never worried. So I will be doing that, but this is not going to be the final measurement setup, so I'm not too fussed about getting it bang on. Alright, now I'll show you some current. On this one I've got a wire wound resistor in the circuit to drive the current, and I'm still using the same variac to apply the volt. So what you'll see is some current go through the whole lot, and some digits on the screen which should be embedded. So I'm just going to put the volts up a little bit. I can't leave it on for too long because those wire wound resistors get really hot. So you can see, you've got a 1/4 of an amp, 6 volts, and that's it on the screen. There you go. Alright, if you want to follow along on this project, hit that subscribe button, hit that like button. Check down in the description for the links to the Datasheet, the Tindie store, which you can buy it. Within that Tindie store, you can actually see the code, which is up on GitHub, that you can use to interface with the IC. And tune in next week, and you'll see some of the power measurements coming through. Maybe a better sort of display to actually see it. See how it goes.